The other thing that we have done right at the beginning, that's a approach that we have taken, was we will do natural navigation. So we will not put in instrumentation, we will not put any kind of markers on the factory floor because that takes a long time to settle down. So commissioning has to be fast, it has to be frictionless. And this has been appreciated by our customer. One example is like we did a recent 10 board deployment and we were in and out within 2 weeks. So this is a 1 acre integrated facility where we do R&D tests and production all in one roof. It's divided into like 3 different halls. There is an interesting tidbit about the history of this facility. It used to be a garment factory, and a lot of these garment owners, their kids have gone abroad, and the garment factories are not run anymore. So we took it up and we gave a new age factory makeover, and that's what you see today. Hall 1 is where we do all our R&D testing. Hall 2 is where all the research goes on. We have an electronics lab, and then we have our software development. Hall 3 is where the assembly happens. I would say we are more applied research. So research that is already available and done by many leading robotics groups around the world. We follow them very closely. There are lots of interesting ideas out there. And why we try to see what of those are applicable to us today, because our customers need to see the value of it in the coming quarters. We don't have the luxury of doing research which is spread over multiple years. But that said, like our hack is we work very closely with research groups at IIIT Hyderabad, Indian Institute of Science, IIT Madras, BITS Hyderabad. So these are faculties there. We consult with them. We work closely with their research groups. We write papers with them. We help out by giving equipment, giving data, so that research is being advanced. So that's something that we do. That's our way to get some insight into the top research that's being happening in the country. So one of the early thought processes while making the Sherpa has held us in good stead. That is to own the full stack. So ground up design and it's purpose driven. So it is. So we own the mechanical design, the electronics hardware, as well as the autonomy software that goes into it. And even beyond the robot, the fleet management software is also something that we develop in-house. So this kind of gives us complete control over the entire stack, and we are able to tightly control the final quality that is being delivered to the customers, as well as we can do like some really nifty optimization across the layers because we control the whole stack. But it comes with a high risk, high reward outcome, so to speak, right? Like the development time does take it takes a while to develop the entire stack. But once you are done with that, we were quickly able to diversify our portfolio to multiple different products. So we started with the Tugger, which is our flagship product. Now we are able to offer lifters, pallet movers, higher tonnage tuggers. So all happened very quickly over the last 12 to 18 months because the platform is entirely owned by us, and we are able to change the drivetrain, change the sensor suite, tweak our software very quickly to turn around and offer our customer newer products. And we, as a company, we are able to approach newer verticals, industry verticals, where we were not able to go in before because of this kind of an approach. So it's been, that's where the versatility comes in, and how we are able to offer all these diversified suite of portfolio. The other thing that we have done right at the beginning, that's a approach that we have taken, was we will do natural navigation. So we'll not put in instrumentation. We will not put any kind of markers on the factory floor because that takes a long time to settle down. So commissioning has to be fast. It has to be frictionless. So these are things that we took a call right up front. And this has been appreciated by our customer. One example is like we did a recent 10 board deployment and we were in and out within 2 weeks. This is something that's unprecedented. You will see these kind of large fleet deployments taking months. But because we are not burdened by putting in these kind of fiduciary markers all over the factory floor, it's like a one-time mapping process that can be shared across all the robots. So that is very helpful. So all you need to do is like, if you put in one robot in commission, the other robots will just follow suit. And we can do like really complex deployments very quickly. I can give you an example of where our robots are carrying their PCB magazines. And these magazines are like finished PCB boards, and they are worth lots of money, say tens of thousands of dollars in each of the load. And they have to be very carefully transported from the soldering station to the finished goods. And one of the reasons they use the robot is it's clean room like. So they don't want too many humans to be touching these magazines and risking the exposure of EMI. But what happened was, because it's such a clean place, they keep vacuuming it. And the person who vacuums the floor, they could leave the vacuum cleaner on the floor and the cable is actually lying on the floor. The robot needs to go around the cable or at least stop and give an alert. It cannot go over the cord because just that jerk can render the whole payload useless. So we had to come up with like quickly come up with like a custom AI model to see what black wires, black cables are like. And then you need to detect that, and that had to get in to our perception stack in short time because they were trying to commission it and they were trying to go live. So this is something that our team were able to do it very quickly. Another kind of perception story is like this was a while back where we had to look for very specific folks of a customer in Chennai, where they had very specific folks and they would come in at a certain angle and you'll not be able to see it. So you had to make a custom model to detect those kind of folks and ensure that the robot is safe and it's not going to go close to that folk or think that it's kind of it's a safe zone to go. So these are like a couple of perception models that we had to develop to do this. And there were places where warehouse type of places where what we call as self-similar environments, they look the same. Even people like you and me can get lost when you're trying to navigate there. And you have to look for very specific landmarks and annotations and put that in your map to make sure that you don't get lost. So these were like tweaks that we had to do on the fly in the software. In terms of hardware, we have done like so many interesting customizations for an automotive components manufacturer in Alabama, where they tug long lines of carts, but it's super curious. They do two lines of tracks at the lines of carts at the same time, and so and they didn't want any operators to come and handle these two line of tracks. So we had to develop a custom auto unhitch, but two of them. So this is with two actuators, and they had to go down one at a time, and you could take out or put back in a single row of carts the way they see fit. Right? So these are things that we have to do all the time. Not to talk about like smart traffic lights where you have to coexist with other forklift drivers or truck drivers. So it becomes like you have your own mini traffic intersections that you create with robots and vehicles that are already there in factory floors. We have done PLC integration where there are legacy robots that are running and you need to hit their PLC server and ask them to stop and yield, or you stop and yield so that there is safe passage for Ati's robots. So there are a bunch of these kind of integrations that we'd have to do. One other thing that comes to mind is like our robots have to go into a lift carry the material, go into the lift. The lift has to be triggered, and then it goes to another level, and then it goes to the other level, cross the road, and then go deliver the goods and come back. So this is like again a unique customization that we had to do for a car, only because we own the whole stack. Okay. So what does that mean? The basic question is like, how would you go about building a robot, right? So you can think of it at one level, software slapped onto a drive-by-wire electric vehicle. What does drive-by-wire mean? You are able, an electric vehicle will be able to. You need to be able to drive it. You need to be able to steer it in a certain direction. You need to be able to brake whenever you want. So drive, steer, and brake are the three operations of an electric vehicle. So all these operations, if you are able to do it by wire, meaning if you are able to expose it to a computer program and you're able to control it through a computer program or a joystick, so that's what it means to say X by wire or drive by wire. Right? Once you have that, any software will be able to control it. And the software is able to control it because it is able to take decisions based on the sensor suite that is placed on the vehicle. And those are the eyes and ears of the vehicle. And based on that, the algorithms run on the software stack, and it's able to take decisions whether to go straight, turn right, brake hard, all those kind of decisions. Right? So that's at the software level. But now, under the hood, do you want to make the drive-by-wire vehicle yourself, or would you like to work with a partner? So that's the key question. And a lot of our competitors do the latter, where they just buy a vehicle from a competitor and they're able to do that. But the approach that we took was all these kind of marriage of software and an existing vehicle has its own quirks, has its own suboptimal decision making, because it's two different entities doing it. Kind of like what you would see with an Android phone, where the Android software is from Google and the underlying hardware is from Samsung or Vivo or Oppo or someone. As against Apple, which says that I'm going to own the entire stack. And they went one level deeper a few years back when they said even the chipset we are going to make it ourselves, and we are not going to rely on Intel to do it. Now this is a risky approach because you are you are responsible for developing the whole stack, but on the other side you have control in customizing anything that you want, right? That is exactly the examples that I was telling, where there were customers who needed a tweak in their mechanical design, the customers who needed a tweak in the hardware design, and the customers who need tweaks in the software design all the time. Almost no customer takes the bot as is. They would need like some sort of software customizations. So these things really, really help us, where we own the entire stack and we can plug and play anything that we see fit. The other thing that I talked about earlier was product development. You can really cut down on product development time and cost if you have this platform approach to developing robots, right? Like the drivetrain might change for a particular robot. The battery might not change very much. It's the same battery that we will use across robots. The electronics boards pretty much remain the same. And the software stack is like say 75-80% reusable across all robots. So this knowledge of developing it full ground up gives you the confidence that you could do a new robot very quickly. And that's what happened to us in the last 15 to 18 months, where we exploded from one robot in our portfolio to 7.